I work on the Roslyn team, the managed languages team, working on C# and Visual Basic. And what we're going to talk about today, we're going to talk about, well, first we're going to talk about Roslyn, kind of what it is, why we built it, all those sorts of things. And then we're going to talk about a particular topic of Roslyn, the analyzers, fixers, and code-aware libraries. It's something we've been trying to share a little bit about, and we've got some new things to talk about there. I want to talk about an overview. I want to give you guys an overview of the APIs for understanding and generating source code. Introduce a brand new API that is kind of in progress right now called iOperation, something that we're working on that I think kind of changes the game for analyzers and fixers. And then we're going to build something. We're going to write some code. I'm okay up here talking to you out there with slides, but I would much prefer to be writing code. So let's talk a little bit about Roslyn. So Roslyn is a project that we started a number of years ago. Well, of course, a number of years ago, right? But around about, we're looking at about 6-7 years ago now, where we decided to really take a look at the existing C# and Visual Basic compilers, which were written in native code. They were written in C++, and rebuild those in C# and Visual Basic, really giving us opportunities to open up kind of the black box, as it were, of the compilers, so that we could now use all of the knowledge of the compiler has around language to to be able to create tools that that are able to introspect source code in a really rich sort of way, to be able to generate source code and write kind of the next generation of tooling on C# and Visual Basic. And of course, this whole journey also included rebuilding the entire stack for C#, including rebuilding the entire IDE and all of the tooling that's in Visual Studio. And today, this gets used in a number of places. Roslyn is used to power Visual Studio Code through a project called OmniSharp. Roslyn is inside of Visual Studio itself in Visual Studio 2015. It's in fact used to power the IDE for Xamarin Studio 6. So it's getting used in a lot of places as a way to really do smart things with C# or Visual Basic source code, including driving tooling experiences like editing experiences, but also scripting and many other applications. So that's just kind of a little bit on Roslyn. Now, what I want to do right now is I kind of want to just dig in and look at some things. I want to look at this idea of analyzers and fixers and this notion of code-aware libraries. And so here's this is actually Visual Studio quote 15, the latest, the next version of Visual Studio. This is preview 2 of that that was released not that long ago. And in this, I have three different styles of analyzers. And when I say an analyzer, I mean something that analyzes source code and produces information for you. So that might be, come in the form of some sort of diagnostic, which is our fancy way of referring to, squiggles in the editor, or the output of a compiler that says, hey, here's an error, we broke, and you weren't able to compile your source code. Or in this case, there are several warnings. So taking a look here, there are a couple of different things to see here. So first, over the var keywords, it's actually showing a couple of different guys right here that are squiggled. Now, var doesn't squiggle in the IDE today, and this is a custom analyzer that we're shipping in the product in Visual Studio 15, and when I hover over it, it tells me I should be using an explicit type instead of var. Now, out there, I'm certain there are people panicking right now that we're going to start squiggling the product every time you use var. And that's not actually the case. What I have here is I have a couple of options that we're introducing for really kind of a general way to look at doing code style in Visual Studio. And so down here, there's a code style node in the options dialog. And we've got a few preferences in here. We're going to do a lot more with this. We have a lot more planned. But right now I have it actually for my preferences on var to actually show a warning. And so I could come in here and if I wanted to, I can change these to errors and say, whenever somebody uses a var on my team, I'm going to want them to be in trouble. So and so those will there we go. and they will resquiggle as errors. So you can see that now I really have to use var, or not use var, as the case may be. And on these, there's also code fixes available with these as well. So this is kind of this part of this this entire experience around light bulbs and error squiggles. This is what we refer to analyzers and then fixers that go along with that. Now, as I said, we're adding several other code style experiences, not just var. I'm going to turn all these off because I actually like var quite a bit. So I'm going to leave that, leave these kind of at those settings. Some other settings that we're looking at adding, code style, are around naming, right? And so the idea that I can define in my source code base how I want various constructs, declarations to be named. And so, for example, and right now this is just kind of the start of what we're going to do here, but we're trying to be as flexible as possible. So, for example, if I wanted to say I want to define something for just, say, methods, right? And we'll say, you know, methods for .NET Conf. Okay? And I want to define that, and I want to give a special naming style for methods. So, for example, maybe I require every method to be prefixed with double underscore because I'm apparently a masochist. That's a terrible idea, but I'm going to do it just for the demo. Oh, and we give it a title. So we'll call this, you know, masochism. All right, and we'll say that's an error. Now, let me give this a good name. Actually, we won't give it a good name. We'll instead just call it name. All right, click OK. And as the solution, you know, sees that these it's time to do some more processing, and so because a change has been made to the options, and it comes through, and now you see that these guys are all squiggled. And if I press Control Dot, it in fact offers me a suggestion to fix that violation. Okay, so we're really trying to take a hard look at this idea of code style in Visual Studio 15 and introduce kind of an entire experience around our analysis and our code fixers, and also marry that together with configuration in the options. Now, I'm doing this all in Tools Options, which is really not ideal for what you want, because that's just global options, right? That means that these just carry along with your Visual Studio, your Microsoft account that you sign into Visual Studio with. That's not really all that great. And so we're also looking at you know, ways that we can carry these along with your project, maybe using something like editor config or some other mechanism to be able to configure these at a project level or even at a folder level, so you can define your style and carry them along with you with your team. So that's one style, and the way this is built into the product right now, and has configuration along with it. Now another one right here is, it's actually might be kind of hard to see, but if you look right here, you'll see that we've got, it's just very faintly fading out the open and close curly brace and the return keywords right here. So the way this is actually coming from an extension, a Visual Studio extension. It's called CSharp Essentials, and it's just a small set of kind of refactorings and analyzers and code fixers that go along. But the idea here is that it's introducing analyzers by fading out this code. That's another form of showing kind of an analyzer might appear in your editor. It's using an analyzer to teach you how to use C# 6 or to move your code over to, say, more of a C# 6 sort of style. So if I press Control Dot on this, it's offering me to use an expression-bodied member, to use more C# 6 sorts of syntactic features. And so this is a really nice way to just kind of get your code up to date and kind of get it more modernized and using the latest and greatest. Now, the last one right here is yet of another kind of style of analyzer with another distribution mechanism. The things that I've shown you so far are either built into Visual Studio, they can come through the Visual Studio extension gallery, and then there's another way, which is through a NuGet package. So these are, what we're seeing here, there's actually a squiggle on customer, and it tells me I should be adding the serializable attribute to customer, since it implements the iSerializable interface. And this actually came from a package I have installed from NuGet called Desktop Analyzers. So if I go to my NuGet packages and look at the ones I've got installed, you'll see this is right here. And it is actually a collection of analyzers, and there's several of these that have been ported over from FXCOP, right? So with FXCOP, it was a build step where you would give it a rule set, and it could take that and run another tool on your compiled binaries after you were done compiling. And many of those rules have been ported over to use Roslyn, so they run right on source code. So they still run in the compiler, and that's how these analyzers really gain a lot of power, because an analyzer through a NuGet or in a reference that is passed down to the compiler can run on your CI server. It can run at build, and it can actually, if it reports an error, it can break your build. But if you do it through in the IDE, then you get kind of this live, interactive experience where it's adding errors or squiggles as you're typing, and also optionally adding code fixes. So several of these have been ported, and they've been ported with code fixers along with them. So I can go ahead and say, yes, go ahead and add that serializable attribute. And then that triggers yet another analyzer to run, which is go ahead and add the serialization constructor, you see. And so you can add these into your project through NuGet, and they appear under the analyzers node over here in references. And so if I expand this, we can see, actually, let me grow this just a little bit. And we can see here are the analyzers that are actually running, that came through NuGet and then got dropped into the special analyzers node. So that's another way that analyzers can appear in the product, and that's extremely powerful. All right. So some of the things we just took a look at really quickly with these three basic kind of ways of distributing and how the ways that analyzers might surface in the product. First of all, we can the important things to take away is that analyzers help you identify errors before compile. Right? They can work during compilation, as I said, but also they can help in the IDE before you even compile. So you can find things, do analysis to detect various things at edit time as opposed to at compile time. You can use them to do things like enforcing code style rules, and we're going to spend a lot more time on that in Visual Studio 15, making that really great. You can do things like introducing best practices for an SDK. So imagine you have a NuGet package that you've authored and it's a library that people are using, but maybe your APIs have ways that they can be used. People kind of get on the wrong trail using an API. You can use an analyzer to set them right back on the right path, right? For example, and then distribute that with your NuGet. And then also, teaching new language features and concepts is another great way to use analyzers. Actually, one of the coolest analyzers we've seen is a set of meta-analyzers that were written by a group of interns that we had at Microsoft, and what they did was they took the idea of writing an analyzer, and they wrote analyzers to teach you how to write analyzers with this whole branching kind of logic, where you had to make decisions, and it would say, well, do you want to build an analyzer this way? And it would generate that piece of code, and then that would cause another analyzer to run. And it was fantastic, but it was an amazing way to kind of teach someone how to perform new tasks or lead them through how to kind of do new things. So, all right, let's talk about API. I want to talk about, in particular, syntactic and semantic APIs in Roslyn, because we're going to take a little bit of a turn here. Instead of looking at analyzers and showing them in the IDE, I want to build stuff. I want to get onto code. So in Roslyn, when we shipped initially, we had two core APIs here for dealing with syntax and semantics. So syntax is, when you're looking at a piece of source code, that it has syntactic structure to it, right? There are nodes and tokens. All the little words can be broken into tokens, and those can be grouped together into logical things, which we tend to call, expressions and statements in the language, and those all get kind of put together in a tree, and then we call that syntax. And then there are semantics, right? And that's what those pieces of syntax actually mean. Right? So, it's one thing to say int in my source code, and it's another thing, more of a semantic thing to say is that's system.int32. Okay? Now, a syntax tree API that we have is a very high fidelity representation of source code. It gets down to the very spaces, the very comments and tokens, and is really designed to be a faithful representation of the language, the underlying language. So there's a version kind of for CSharp, and there's a version for Visual Basic. Those are very much very similar in look, but they are two distinct APIs that that really give a very, very, very detailed and granular kind of view of the source code. And you need that if you're doing a lot of refactoring or source code transformations at that granular level. You need those APIs. And then we offered a semantic model API where you could say, given a syntax tree, I would like a semantic model. And this is a kind of an object that allows you to kind of ask semantic questions about syntax in the syntax tree that it's associated with. So if I have some expression, say I have the literal, 0, I want to ask, well, what is the type of that? I could go to the semantic model and pass that piece of syntax, the expression, right from the syntax tree and say, give me, what is the actual type of that? And it would tell me, okay, that's system.int32. Now, right now, we're looking at a set of APIs that kind of take an evolutionary approach, right? So these are great, and they work really, really well, and we can build some really great things with them, and they are necessary. But when it comes to doing things at this very granular level, it can be very tedious as well. And sometimes it seems like, well, there are just too many ways to write something in a language. And we'll look at an example of that in a moment. And also, having to write it once for C#, once for Visual Basic, also can be problematic. So we've introduced in kind of a preview form this in-progress API, and we are in kind of active development on this API, but we call it iOperation. And it allows you to essentially get a similar to a syntax tree where you can get kind of a tree view, more of a that is simply more of a semantic tree over your source code that doesn't get down to the most granular level in the source code, but provides you kind of a common view that abstracts over some of these kind of the nitty-gritty. And it also provides a common representation for C# and VB. But the important thing, the really important difference between this and the APIs that existed before is where we had syntax and a semantic model where you would ask questions about syntax. In this case, you get back a tree where all the semantics are already there, right? And it's already kind of baked for you. So if you want to ask a bunch of semantic questions about a particular node type, you can ask for an operation and get all of that information. And then I also want to, we've also put in the syntax generator API. This kind of went in really kind of hush-hush, kind of under the radar, just as we were about shipping Visual Studio 2015. And this is actually an abstraction that allows you to generate source code for C# or Visual Basic, but using the same code. You don't have to go and write a specific version for C# and a specific version for Visual Basic. Now it's kind of limited in what you can do. But you can get pretty far with it, and we'll take a look at that. So I have a question from Andre. What's the performance impact of using analyzers and fixes on the editing speed? Well, Andre, the performance impact is tricky to determine. But it's extremely important to us now. Obviously, there's a lot more work happening as things are kind of happening asynchronously, and just kind of going and analyzing all of the source code, in your solution. So what we've done is we try very hard to be smart about how we order that work, right? So that when you're in an open file, that's getting analyzed. That's always going to be promoted and be analyzed first, right? So the places where you're making your changes are the places where we're constantly doing the analysis so that we're not kind of, going off and doing other work that might not be as related. And that's the sort of thing that would slow down your typing if you didn't get immediate feedback. So something that we're constantly tuning, but it is pretty good. I'm not going to lie, it is pretty good, but we are still in process of tuning it to make it even better. So, all right. Now, let's actually build something. And I want to use these new APIs, these iOperation and syntax generator. Again, they're APIs that are in progress. So at least the iOperation is in progress. We're still continuing to tweak the syntax generator and add more things to it that you can generate with it. But what I want to build is I want to build an analyzer that detects when you are newing up a zero-length array. Okay? Zero-length arrays are, well, they're just an allocation. And every time you have one of these, it's a heap allocation in your application. And so in .NET 4.6, we introduced array.empty as kind of a helper method. And that allows you, if you use that allows you to share the same instance among all of these. So I would like to write an analyzer that detects these cases and then offers a fix to change it to array.empty. All right. So let me go ahead and pick a different solution here. Now I've gone ahead and I've installed on this project in this instance of Visual Studio, I've installed the .NET Compiler Platform SDK. That's the fancy name for Roslyn, .NET Compiler Platform. That's if you feel extra fancy and you've got a lot of extra kind of syllables that you want to get out, that's the way to call that. We just call it Roslyn, but but if you're looking for, this is the SDK that helps you, that gives you the templates and the tools you need to write analyzers in the product. And so I've already created this project so that we can kind of get going on it. The initial project has some kind of boilerplate code that I've already deleted, but this should just get us started. Now, if I want to run this right away, it will actually do nothing. But what I have to do when I'm writing an analyzer, now first I've got some metadata up here that gives me various things that describe my diagnostic analyzers, so things like the title and the message format, things that I might want to put there. I might want to change this, for example. This one's not going to be about naming. This is going to be some kind of FX cop thing, kind of thing. And we should probably, just to prove to you that we're actually doing something, I'm going to give it, in the resources, I'm going to give it some something fun here. So we should give it a, let's give it a .NET Conf right here. That should give us a, we'll do the same thing in the message. And that way it appears and you guys will know that I'm not lying, that I'm really building this thing. All right. So now in an analyzer, this is a bunch of junk, so I'm just gonna collapse this so we don't have to look at it. And the first thing we want to do is to define some actions that we want to basically give, say, for particular events that happen during analysis, I'm going to declare some actions, some callbacks that get called. And we do this in the initialize method. This gets called whenever analysis kind of gets kicked off. And it passes us an object called an analysis context. And this context object, just take a look at it in IntelliSense, has all sorts of things on it. It has some terrifying things like enable concurrent execution. Who knows what that does? No, I mean, it's scary. But then there's all these register methods, and that's the important part here. They give us various events that can occur during analysis that we might want to subscribe to and listen to. Now, I'm interested right now, we're going to start out by looking at register compilation start action. This is essentially gets fired whenever analysis kind of kicks off and begins, right? Right as soon as we have a compilation object that we can talk to, this event fires. And so I'm going to come in here and I'm going to say register compilation start action. Then I pass in an action, and that will give me a different type of context, a compilation start analysis context. So I'm going to declare a lambda right here, and that C is our context. Now, the first thing I want to do, because if you recall, we're going to create something that detects a new array that is created empty, but I only want to detect this if array.empty is actually available to fix it to, right? Because if I just report that you're newing up empty arrays and I don't give you a way to fix it, there's no way for you to deal with that. That's kind of irritating, right? You would hate me, I think, if I did that. So what I'm going to do instead is I'm going to check first to make sure that array.empty is actually available in this particular compilation, right? And then if it's not, we won't do the analysis. So the first thing I'll do is I'm going to walk up to the context, and I'm going to grab the compilation, and I'm going to call a method called getTypeByMetadataName. And so I can give it its name that would be found in metadata, its fully qualified name, which is system.array, to get back the array type. Okay. Next, we'll come in here and we'll check first. We'll use the null conditional operator to double check that we actually got something there, and then I'm going to get the members on here that are called empty. Okay. And if that actually not null, we want to actually, because it's giving back an array, we want to check the length of that and make sure that we actually have something. We have something more than 0. Okay. So essentially, there could be overloads of empty, And if we wanted to be really specific, particular about this, we could also check to make sure that we have a member that is parameterless and takes one generic type parameter. But this is good enough for now. So at this point, we've established that the type and the member exist. And so we'll go ahead and register a new action. So nested inside of this particular action, we can register more actions on this context. Looking at the context, there are various things on here, and also more registration actions, which basically say, now that I found this in this callback, let me go register another callback, and I can kind of chain things together and nest sort of my analysis. And so in this case, in a past demo, I might have done register syntax node action and looked around for particular syntax. In this case, I want to register an operation. And let's actually, before we dig into that, we should figure out what it is we want to get. Right? What sort of syntax are we looking at? Because what we want to do here is we want to essentially take code like this, whoops, like that, and we want to take this part and we want to turn it into array.empty. Now, I'm going to use a tool that installs the .NET Compiler Platform SDK to get a sense of what that actually is. This is called the Syntax Visualizer. It's actually available from View, Other Windows, Syntax Visualizer down here when you install the SDK. It installs that for you. And that gives us a way to look over here at the tree, the actual Roslyn syntax tree and all of the nodes inside of it. And you can see it, as I click here, it'll move around and show me all the various pieces. So here's the attribute list. There's even the keywords are there, even the leading and trailing white space is represented in this tree. Now, I'm interested in this part right here, which is an array creation expression. Okay, so and you can see under there's kind of a new keyword. There's an array type. That's what I want, and I want to turn it into that array.empty. Now, I'm going to show you. There's an easier way to look at this. I can right-click on that node and view a directed syntax a graph of that, and that gives me kind of a nice pretty view of that particular subtree. And so we can see the array creation expression, the new keyword, the array type beneath that. There's a predefined type node there because that's where the type goes, but in this case it happens to be int, which is predefined in the language. And then there's the array rank specifier where we put a numeric literal 0. Okay, so not that complicated, but that's how granular the Syntax API can get. Okay. Now, one of the concerns here, though, is there's actually another way to write a zero-length empty array in C#, right? And that's if I write it like this. So I can also say, instead of putting a rank specifier there, I could write it like this. And that's not really convenient, because if I'm writing an analyzer on syntax, specifically on syntax, that means I need to handle both of these different shapes, kind of shapes or forms in the language. And if I look again at the syntax visualizer, we'll see that, in fact, this is really, really different. So looking at my, where are we at here? There we go. There it is. The array creation expression for this, it actually looks quite a bit different if I view a directed syntax graph. So in this case, yes, there's a new keyword, and there's an array type, and an array rank specifier again. But in this case, there's actually a special expression where it says that size, that array size was omitted, right? And then there's an array initializer where the compiler goes and figures out, oh yes, this has no elements. And so this is yet another form that we'd have to look at. And that's not really ideal. So what I want to do instead is look at IOperation. And the way we're going to kind of sort that out, it's not the greatest way of doing this yet, but it's a start. I want to look at IOperation. I'm going to go to source.roslyn.io. That is where we have our reference source for the Roslyn code base, and it is generally fairly up to date. And I can look around for things like array creation. And there are various types of this. There's the array creation syntax that's actually in the C# language. But all of the operation API elements all start with I because they're all interfaces. So I'll come in here and say, I array creation expression. And that's the one I'm looking for, right? And here I can find all the operations that I need. We'll be working on tools to make it easier to discover operations, but at the moment, use the source. All right, so I'm looking for an I array creation expression. So I'll come here and I'm going to delete this code, and now I'm going to register a new callback. I'm going to register an operation action, which takes yet another action that has an operation analysis context in it that will give us the data we need once this particular operation we care about is actually analyzed, and then a params array of operation kinds. And there I will say, hey, I'm interested only in array creations. So I'm going to say analyze array creation. We'll create a new method called that in just a moment. And then I'm going to pass in the operation kind array creation expression. Okay? And so that tells it, hey, here's our callback, but only call it when an analysis is completed for an array creation expression, and give us the information at that point. So I'm going to press Control Dot to bring up generate method stub, generate that down here, and let's go ahead and give this a better name. It's kind of obj is kind of terrible for actually writing code. Delete this bit, and now let's go ahead and write the code we need to detect whether the array creation is basically just is empty. So first of all, I'll check the context. The context itself has a few items on it, has some interesting bits, but most importantly, it has this operation. Now, because we've registered it for just one type of operation kind, I'm going to go ahead and assume that that is in fact an I array creation expression. Okay. We can just cast context.operation to that. All right. And then we're going to do the work. We'll check and say, does this have, just one rank in it, one dimension actually in this case, because now we're looking at semantics. We're no longer looking directly at those little directed syntax graphs where we have with syntax. We're looking at more of a kind of a smeared view that just kind of represents the shape of an array creation expression as opposed to the specific syntax. So in here we have things like, what are the dimension sizes? And this is going to be a single dimension array. So I'm really only interested in dimension sizes of 1, right? And so I'll check that. And then we want to make sure that the dimension size has a constant value. Just because it's something we need to be able to get that value out, we need to be able to check that it's 0, right? That it's actually 0. And this will work if even if it's actually a constant that is used as an identifier here, but it's a constant somewhere else. It'll go ahead and this will happen as part of constant folding, and we'll actually get the real value here. So now I'm just going to dig this out, dimension size, and we'll go ahead and grab dimension sizes 0. Actually, we're going to grab the constant value and get its actual value. I'm going to pick a better name. We'll just call it value. Now, if value is int, we want to make sure it's actually an int, because this is an object. It's the actual real numeric value, not the text 0 or anything like that, but the real number. So we want to check and see if it's an int, and then if it is, we can cast it and make sure it's equal to 0, and then we're good. But that kind of looks really bad, we've been working on this new feature called pattern matching, which looks like it would work really, really well there. It seems silly that I have to do an is check for int and then cast it. I mean, it seems like I could just do this, right? And just say if it's I and I is equal to 0. And so I may have turned on pattern matching in this build, and it might work really well. So these are kind of a feature that we're working hard on getting into C# 7. But even that looks a little weird. It'd be probably better if I just did this, right? Shh, don't tell anybody I told you about this. All right. So now that we know that the value is 0, we'll go ahead and create a diagnostic. Now I'm going to pass in here, up in the metadata block up here that I've got, this kind of all this stuff, there's a rule that describes our diagnostic and kind of identifies it and puts all the additional text to it. So we'll pass that in here, our rule that's created for us by the template. And then I'm going to go to the iCreation operation again. And the great thing about operation is that, yes, it's doing this wonderful kind of abstraction over shapes in your source code, but you can always get back to the syntax. Okay? And so I want to get back to the syntax because I need to pass in the location where the diagnostic should be reported. Where should the error squiggle be, right? And so I go there to the syntax and I say, give me the location of that, and that creates my diagnostic. Now, the last thing I should do then is report it. And that should do the trick. Now, this is about, oh golly, I don't know, ignoring boilerplate, maybe less than 20 lines of code, to do something pretty substantial. So I'm going to go ahead and F5 this, and that will start up a new instance of Visual Studio, assuming it builds correctly. If it doesn't build correctly, I'm going to crash and burn in front of you. So while it's coming up, so how to create a code? There's a question from Vikas. How to create a code style rule if method is async, having async tasks? So method name should be suffixed with async. Well, the way you could do that, again, this is something we're working on. We want this to be as flexible as possible. Okay, so in the naming rules, right here, I'm allowed to do things with the symbol specification. Okay, and wow, that's because I put the debugger up. That's an interesting kind of experience. But in the symbol specification, I can choose things down here like modifiers, and it must match them all. So I could come in and say, well, I only care about methods that are async, okay, that have the async modifier. And we'll say that. We'll say methods with async modifier, methods with async. And then, for the naming style, I would come in and I'd say the required suffix is in fact async. Okay, and that would be a way you could set that code style up. I should mention that we're still, whoops, cancel out of this, I didn't give it a name. We're working on this to try and make it as flexible as possible because we want to be able to do things like represent the code style rules, for example, for the CoreFX code base. For the core framework. And that's actually really tricky because we have rules that are very, very, I want to say it's extremely robust, kind of the rules we'd need to be able to express in here. So for example, static fields are prefixed with S underscore, but static fields that have the static local attribute are prefixed with like G underscore, for example. And so we are working on a way that an extender, someone who's trying to extend code style or with an analyzer, can actually add in new kinds of tags in here. Something we're just talking about right now. Might not make V1. Don't take me at my word on that one, but it is something that we're looking at. RAS, is there an easier way to provide analyzers across an organization, maybe packaged through VS extensions? Yes, you can package analyzers in VS extensions. The CSharp Essentials extension I showed at the very, very beginning is a Visual Studio extension that includes analyzers and fixers and even refactorings as an extension to Visual Studio. Also, if you have a set of analyzers that you use within an organization, it could also be distributed via NuGet that you include in your organization's packages, or maybe it's on your organization's custom NuGet feed or something like that. So yeah, that is definitely something you can do. Okay, what was I doing before I asked questions? Oh yeah, we were going to look at the code, see if the code worked. I'll remind you what the code looked like. All right, not much to it, but what we're trying to do is detect those empty arrays. And so I'm going to open this solution, and I've got it right up here. I've got two arrays being newed up right now, and if all goes well, lo and behold, in fact, it does work. Okay, and you can see it says .NET Conf on it to prove to you that I'm not doing any sort of sleight of hand here. We compiled, and it's working. So, and the important part is that I wrote one piece of code, one piece of analysis that detected both of these shapes, these syntactic forms for an empty array in C#. That's pretty awesome. Okay, well, let's do the other side of this. Let's write the fixer, the thing that says turn it into an array.empty. Writing the actual diagnostic is a small piece of code, but now we're actually going to get in and start changing code, and that can be really tricky to get right. And it also is something that the Syntax API has been kind of kind of formidable at giving you a way to do it. It's very, very, very complicated in the sense that you have to do every single thing just right. And then you need to do it once for C#, and if you want it for Visual Basic, you have to do it again. So let's try this using the syntax generator API I mentioned earlier. All right, so this is our CodeFixProvider. Again, there's normally boilerplate in here, but I've deleted the boilerplate so we can just get started writing code. And the place where our entry point is in register CodeFix's async. Okay, and in here, I'm going to go ahead and the way this works is essentially our diagnostic has an ID associated with it. It's in that block of metadata that I collapsed up here. There is a diagnostic ID right up here called zero size array analyzer. Okay, now our CodeFixProvider has a property on it called fixable diagnostic IDs. And essentially these are the diagnostic IDs to which this CodeFix responds to, right? So it knows it's going to be called with this, only when this diagnostic is found. And it returns just one, it returns the diagnostic ID for our zero size array diagnostic analyzer right here, okay? And so we know that there's only ever going to be a singular diagnostic ID that we're ever called for. You can write code fixes that respond to lots of different IDs. We're only going to ever deal with one. And so I'm going to go ahead and just assume that there's just at least one in here, but that it's essentially the same thing. So I'm going to grab the very first diagnostic that's passed in through, again, another context objects. And this is how we kind of communicate through these objects. They're all called context. Now, it has within it the diagnostic on which this code fix is being called. And from that, we can get at the diagnostic span in the source code, because this diagnostic is, again, it's representing kind of the squiggle that's in the editor. Now, what's interesting is that the code fix happens, the way that we do this is our currency is to pass diagnostics back and forth. We don't pass syntax back and forth. And so once you're writing a code fix for a diagnostic, it's kind of up to you to go back and find the piece of code that you're interested in. And so usually you take the diagnostic span and go find the node around that to do that work. So I'm going to do that in just a moment, but the first thing we're going to do is we're going to register our code fix. And the way that we do that, we pass in a CodeAction and a diagnostic. Now the first thing I'm going to actually, let's just make sure we pass that diagnostic first. But then we'll come in the second parameter and we go to create a new code action. A code action is kind of this abstraction, this bundle of this object that kind of represents a code change that's going to happen, but not just a source code change. It could actually represent a change in the solution itself. You could do various things, add references to projects or all sorts of things in here by making a change that's larger than the document itself. Within the Roslyn API, there is a kind of a representation of document, project, and solution that you can change and within a code action. And this is done all through kind of an immutable snapshot sort of model. So we don't actually make changes to Visual Studio. We make changes to this model in the code action, and then that model can be used to do things like either actually apply it to Visual Studio and make the changes, or it could be used to create a preview. That editor preview uses the exact same technique. So what we're going to do is we're going to pass into this code action. Let's create one of these. We'll pass in a title, and I've got it up there at the top of the class. It says use array.empty of t. And then we're going to pass in a delegate, a lambda expression, to create a change document. So it's going to give us a document where this code fix is being run, where the diagnostic appeared and the user has decided to run a code fix. It's going to give you that document, and then it's going to say, now give me back the document changed with the fix already applied. And so I'm going to just pass a lambda expression here. Notice that it takes a cancellation token as its first parameter. And then we're just going to go ahead and, again, create a new method called useArrayEmptyAsync, we'll say. Pass in the document off the context. Now the context has several things, the diagnostics and various things, but we're going to pass in the document, the span, and the cancellation token that's passed to us, right? So a lot of things get, often we get cancellation tokens when we're working on analyzers or on code fixes, and that's because, especially with analyzers, the user might still be typing in the editor, and if you're doing expensive work, we want to cancel that work so it's not still going on if the user's already moved on or, completely, selected the entire file and commented it out. We want to be able to cancel that work so things still stay efficient. We're not doing unnecessary things. And so in this case, it passes me a cancellation token I can use. I'm going to pass it into this method. All right, and we need one more paren, I believe, and there we go. And then I'm going to use, again, generate method stub to just generate that method for me. Now, this is, in fact, intended to be async. It returns a task of document, so I can do this work asynchronously. One thing that's important to note is that the analyzer engine does a lot of work to make sure that it calls you in the same manner, in which the same context in which every time when you await something. So it does a lot of work to make sure that you don't have to worry about that sort of thing. You can just await various asynchronous APIs and move on normally without having to worry about producing deadlocks or anything like that. So just bearing that in mind. Now, the first thing I want to do is the document itself has lots of things kind of bound up in it. They're lazily kind of computed, but things like the syntax tree itself, I can get at a syntax tree of the source code that the document contains. I can get at the text itself. I can get at a semantic model. And what I usually do, though, is I get at the syntax root. That's the actual top node in the tree itself. So we're going to go for the syntax root. And I go to the document, and I say get syntax root async. And the reason this is asynchronous is because the document itself is lazily computed, the information inside of it. And it's entirely possible that this might hit the disk. It might load this might represent a closed file. It might now load the file. It might parse it. We try to do things not as much work up front and do them as needed asynchronously. So that's what will happen in this case. And we can pass in our cancellation token right here. Then, now that we've got the syntax root, I can use that to find our array creation. I can go to syntax root, find node, passing in a span, the span of our diagnostic. And this will, because if you recall in our diagnostic analyzer, we simply squiggled, we created a diagnostic for the span, the location of the array creation expression, the actual syntax. We went back down and got the syntax out so we could do that. So now I have this span. I should be able to find it right back just by passing the span in here and saying find the node whose particular bounds match this particular span. So I'm going to go ahead and say array creation node, and I'm just going to assume that that's in good shape because I already performed the analysis to do that in the diagnostic analyzer. All right, so next I want to ask some semantic questions. So I'm going to go grab the semantic model, and again I'm going to go to the document and I'm going to, this is asynchronous, and again it shouldn't do a lot of work because we've already gotten the syntax root, but it might do some extra work to make this possible, because getting a semantic model might mean, because the semantics will depend on the rest of the files in the compilation, right? And so it might need to walk up to the project and build up kind of a larger body of information to be able to give you proper semantics for this document. So again, that's asynchronous. But with this semantic model, I can now go back and get the operation for this piece of syntax. So I'm going to call this array creation op, and go to semantic model get, and there's all sorts of get members in here, but there's get operation is one of the new ones that we're working on. And I can just pass in my node, the syntax above. I know that this is going to come back again, like I did before on the diagnostic analyzer side, as an array creation expression. All right. And then the next thing I want to do, because I'm going to have to go ahead and generate this array.empty. I'm going to get the array type so that I can do that a little bit better. So we're going to do very similar code to what we did in the diagnostic analyzer, where I'm going to go to though this time I'm going to go to the semantic model to get the compilation that the semantic model this document is a part of, and call that get type by metadata names. Very handy, and I can pass in system.array and get back the array type that I know is there. Ooh, and I have an extra R. You guys didn't tell me. Come on. All right. Next up, I want to generate the actual array.empty, the actual expression that does that. And I'm going to take a look at it really quickly, kind of look at what it is I want to write. Now, this particular analyzer is not built on 4.6, so I don't have it in here. But that's okay. Right now I'm just worried about syntax, right? I'm just trying to construct syntax. So I'm going to write it like this, and it'll have a squiggle because there is no array.empty. That's okay. And I'll come on and look at the syntax visualizer and go right on here, and we'll see that the key things are that I need an invocation expression. That's the thing that actually calls an expression with parentheses and actually with an argument list. Inside that is a simple member access expression. And then here is a name, right? There's a generic name here for empty of int. And so I'm going to use the syntax generator to do that work, to generate this for us. And just so that we can, if it's easier for you guys to see, here's the directed syntax graph of what I need to construct. And if I needed to construct that one token at a time, that would be, again, very frustrating for both me and for you watching. So I'm not going to do that. I will use the generator class. All right, so let me get a generator. And the way I do that, let me close this syntax visualizer down. The way I do that is I walk up to syntax generator. Is a type. It's in the Microsoft.codeanalysis.editing namespace. And I call a method called getGenerator. Okay? And that can take a document. And well, I have a document. And what this does is it gives me back a generator that is appropriate for that document to either produce C# or Visual Basic. All right. Now the first thing I want to do is I'm actually going to generate two expressions. I need to generate the name of the array, right? So that I can put it into, because I need to call array.empty. And those are two different expressions separated by a dot in a member access expression. So I'm going to generate the left side first. And I'll do that right here, saying array type expr equals generator. I'm actually going to go fairly quickly. Produce a type expression, passing in the array type. You're going to have to hang with me. I'm going to run out of time, so I need to start going faster. And then I'm going to generate the right side, the empty part. And it's going to be called member name. I'm going to call generate generic name. It's going to be called empty, spelled correctly. And then for the type of this generic name, I'm going to pass in the actual element type from our operation. The operation is the array creation expression. The type of that is the thing I need to pass in as my generic type argument. Then I'll create a member access expression. Going quickly, array type expression. This kind of glues those expressions together. The array type expression on the left side with the member name on the right side. And then we wrap the whole thing in an invocation expression. Generator invocation expression. You can see on that generator there are all sorts of different node types you can create. And the great thing about this is that it works across C# and Visual Basic, and it lets you kind of abstract over the languages without having to deal with, nodes and without having to deal with tokens and the white space between them and all of that. So now I'm going to take my syntax root and I'm going to replace the original node, which was the array creation node, right up here, the original one I got, with the one I just created, the invocation expression. And I'll return from this the document with our new syntax root. Okay? And let's F5. Let's see if it works. While it's coming up, there's a question out there. Are there any Visual Studio license requirements for these analyzers? No, there are not. These are intended to be run on CI servers. They're intended to be everywhere, and so they are in the very lowest SKUs. Again, and they run in Xamarin Studio 6, and also working on getting them running in Visual Studio Code. So this is an experience that we feel should be ubiquitous. All right, so here we are back in our source code. There are two light bulbs here, and if I press Control dot to bring up that light bulb, I in fact see array.empty being introduced, and so that is fantastic. It also works on this one just like I want it to, and you see the preview. We get that for free, and then something else we kind of get for free because of the new syntax generator and because of the new IOperation API is that we get the squiggle in Visual Basic. Even though this is the same code running, And in fact, if you look, it says .NET Conf right there. This is exactly the same thing we just wrote. So it runs on C# and it runs on Visual Basic because we use these new general APIs to abstract. All right. So that's just a quick look at how we build an analyzer. It doesn't take a lot of work. Again, both of those were around or under about 20 lines of code. And there are tools out there to help you do that with a syntax visualizer. Now, so the call to action for you guys who are watching, explore and use some of the existing analyzers that are out there. There are a lot out there. Some of the code cracker stuff and style cop analyzers. There's a number of analyzers that the community is building and that we are building. Or try to build some yourself and give us feedback. There's some contact info for you, and thanks for watching. Coming up next is Philip Carter, who's presenting F# for the practical developer. So, and thank you very much.